Common external tangent is going to be between these 2 points. Okay, so it's this thicker portion of that line. Okay, you're told that the radius of the small circle, the radius of the larger circle are 3 and 8, and you want to find, and you are again told that the distance of the centers from one another is 13 units. Okay, and you want to find what is the length of that common external tangent. Okay, in order to solve this problem, what you're going to do is create a right triangle. And the way that you're going to do that is you're going to take the center of the smaller circle, and you're going to, from that center, you're going to construct a line that's perpendicular to the radius drawn from that center. Okay, so what that means is if I take this segment from this center and connect it from that radius to the other radius so that it's perpendicular. Okay. Again, what do I know about the radius and the tangent line? They intersect at what angle? 90. So what kind of a figure did I create right here? A rectangle. And in a rectangle, what do you know about the opposite sides? They're equal. So here's our unknown. This is what we're looking to solve for. So what does that mean this length up here is? X. And then if this length is 3, what does that mean this portion is? 3. Which leaves what for this portion up here? 5. Okay, once you get that value, you can now use this right triangle that's created in here. Okay, and can you solve for x? Again, I use a pretty convenient number, right? What's x going to be? 12. So we get our answer to be 12. How do you know that x is 12 in this triangle? We have a 5, blank, 13. Is this a common triple? Yeah. Now, if you didn't remember that that's a common triple, could you have used Pythagorean theorem on this as well? Yeah, you could have said 13 squared minus 5 squared equals x squared, or x squared, or 5 squared plus x squared equals 13 squared to solve it. But once again, if you are familiar with your patterns, you can come up with the answer quickly. Okay, but regardless, this is kind of the format you're going to see on these common external tangent problems. You're going to take your smaller circle from the center, create a line perpendicular to that radius, connect it to the other radius. That'll create a right triangle inside and a rectangle below. And then you use the properties of a rectangle to figure out the remaining values. Plug it in, and then Pythagorean theorem or the properties of right triangles that you are familiar with will be used to solve.